Star formation and evolution. Introduction. Stars, the building blocks of galaxies, follow a fascinating life cycle. They are born in vast clouds of gas and dust, undergo different evolutionary stages, and eventually die, often in spectacular ways. Understanding how stars form and evolve helps us comprehend the structure and dynamics of the universe. Birth of a star. Stars form in nebulae, which are clouds of gas, mostly hydrogen and dust. Gravitational forces cause these clouds to collapse and condense. As the material compacts, it heats up, eventually reaching temperatures high enough for nuclear fusion to begin at the core, marking the birth of a star. Main sequence stage. Once nuclear fusion starts, a star enters the longest phase of its life, the main sequence. During this stage, hydrogen atoms fuse into helium in the star's core, producing immense amounts of energy. Stars like our Sun remain in this stable phase for billions of years. Red giants and supergiants. As a star exhausts its hydrogen fuel, the core contracts while the outer layers expand, forming a red giant or supergiant, depending on the star's initial mass. This stage represents the beginning of the end for a star, as it can no longer maintain stable nuclear fusion in its core. End of a star's life. The death of a star depends on its mass. Low-mass stars, like the Sun, shed their outer layers, forming planetary nebulae, while the core becomes a white dwarf. Massive stars, however, may end in supernova explosions, leaving behind neutron stars or black holes. White dwarfs. A white dwarf is the remnant core of a low-mass star. It no longer undergoes nuclear fusion and gradually cools over time. Though no longer producing energy, white dwarfs can shine for billions of years before fading into darkness as black dwarfs. Neutron stars and black holes. For more massive stars, the core collapses after a supernova. If the remaining core is between 1.4 to 3 times the mass of the Sun, it becomes a neutron star. If it exceeds this limit, the core collapses into a black hole, a region of space where gravity is so strong that not even light can escape. Stellar evolution and the universe. The evolution of stars plays a crucial role in enriching the universe with elements. Heavier elements, such as carbon and oxygen, are forged in the cores of stars and spread through supernova explosions, seeding future star and planet formation. Conclusion. Stars undergo a remarkable life cycle, from their birth in nebulae to their eventual death as white dwarfs, neutron stars, or black holes. These processes not only illuminate the universe but also shape its chemical makeup, influencing the formation of future stars and planets.